Here I want to show you if x is a discrete random variable with possible values of, say, x1, x2, x3, and so on, then there will be corresponding probability distribution of P1, P2, P3, all the way up to Pn, such that the probabilities have to add up to 1. Mathematically, we'll write this as the sum of the probabilities from where we start with 1 and we'll go all the way up to n, and that should be probability 1 plus probability 2 plus probability 3 all the way up to probability n, and that should equal to 1. So let's look at an example where a supermarket has 4 checkouts. We'll call them A, B, C, and D. And the management wants to find out whether they add up properly. The discrete random variable x is going to be the number of machines that are accurate. So what values of x? We can have all 4 machines accurate. So we'll give them a tick. Or we could have 3 machines accurate and one of them is faulty. Or we could have 2 machines that are faulty and 2 that are accurate. And also I could have 1 accurate and 3 faulty. And finally I could have all of them faulty and none of them accurate. And so the values for x for all the accurate ones, x here would be 4 accurate. Here, x will be 3 accurate. Here, the values of x will be 2 accurate. Here, the value of x will be 1 accurate. And finally, we have no accuracy. So we've got 5 values, 0, 1, 2, 3, and 4 for the discrete random variable. Altogether, you can see that we had 16 possibilities. So the probabilities of each one would be 1 out of 16. The probability of getting 3 will be 4 out of 16. The probability of getting 2 will be 6 out of 16. And here we'll have again 4 out of 16. And finally 5 will have 1 out of 16. And so the sum of our probabilities will be probability 1 plus probability 2 plus probability 3 plus probability 4 plus probability 5. And they all should add up to 1. So let's check. And yes, when you all add them up, they do indeed add up to 1. And you can see that there is a distribution of probabilities. They are all different, and we can actually show it on a graph. And so when the discrete is 0, 1, 2, 3, 4, and the probabilities are 1 on 16, 4 on 16, 6 on 16, 4 on 16, and 1 on 16. And so we could represent this on a probability graph where this is going to be our probability and our discrete variable x is on the x-axis. And so as we graph them, that's 1. And so our graph, as you can see, has this probability distribution, which looks pretty normal here. And not all distributions are so well balanced to look normal. Some of them are skewed either to the right or to the left, and also we have some which are completely uniform. In my next video, I'll show you what a uniform discrete probability distribution looks like.